We are aware of this as we contemplate the Sun, of its enormous power and the energy it emits. It traverses the entire solar system. It is hard to imagine anything capable of surpassing our Sun. Yet beyond our own star lies a cosmic wonder that makes even the mightiest solar giants seem insignificant in comparison. Voju, the red supergiant, defies explanation with its enormous diameter, irregular pulsations, and unpredictable behavior. The star is a mystery to researchers who are still studying its power and potential. As they take a deeper look at this magnificent star, they have discovered something terrifying. Join us on this journey as we delve into the constellation Orion with the James Webb Telescope and explore how its presence could change our understanding of the universe and its impact on the cosmos. If you're interested in learning more about news from the universe and its distant regions, subscribe to our channel. Be sure to like this video and turn on notifications. Though many people overlook this fact, Betelgeuse, also known as Voju, can be seen in the night sky during the winter months in the northern hemisphere. Just look up at the sky and focus on the constellations Orion and Canis Major to view this brilliant star in all its splendor. There you can easily locate the reddish-orange star that marks the upper left corner of the rectangular shape of the constellation. The star is one of the largest and brightest in the night sky, making it difficult to miss. However, if you've looked closely at the star, you may have noticed that it does not remain constant. In fact, it varies in brightness periodically. This peculiarity is no coincidence. Voju, as the star is called, is no ordinary celestial object. Despite the fact that it may appear to be just another star in the vast firmament, it is located at a distance of more than 640 light-years from us. At first glance, this number may not appear impressive, but in reality, it represents an enormous distance. To illustrate this magnitude, let's imagine we could travel at the speed of light, which unfortunately is not currently possible. Even in that hypothetical scenario, it would take us more than 640 years to reach Voju. If we were to undertake such a journey with our most advanced spacecraft technologies, it would take more than 12 million years to get there. This figure far exceeds the entire history of human civilization on Earth. However, the faint light from Voju is not only due to its vast distance. The term red supergiant refers to an ancient massive star that undergoes both expansion and contraction. During these cycles, its brightness varies in the night sky, becoming more intense or dimmer over time. These changes can occur over extended periods, ranging from tens to hundreds of days. Remarkably, Voju can oscillate in brightness over a wide range. It can vary from near magnitude, 0.5, to nearly zero magnitude, making it extremely bright. These changes follow cycles, with the shortest being 185 days and the longest 2,835 days. At times, Voju can become quite faint, reaching what's called van magnitude. In February 2021, it reportedly had its lowest van magnitude in a long time, at plus 1.614. Despite its relative brightness, it certainly appeared fainter than what we usually observe. Yet brightness is not the only notable feature of the star. Voju is also known for its distinctive reddish color, caused by its cool surface temperature of about 3,500 Kelvin. This is significantly lower than the surface of our Sun, which reaches around 5,500 Kelvin. The lower temperature means Voju emits much less energy per unit area compared to the Sun. That's why, despite being one of the largest stars in existence, it appears relatively dim. Voju is like an enormous being, content with a low profile It doesn't need to show off its size to make an impact. But don't be fooled by its appearance. Betelgeuse is a supergiant star with about 20 times the mass of our Sun. This is one of the reasons it has served as the subject of numerous studies over the centuries. It has commanded attention in the night sky since ancient times. It was first identified by the Greek astronomer Ptolemy, and its name in Arabic means Orion's armpit. Although little could be known about Betelgeuse at the time, modern telescopes have enabled researchers to investigate this star in greater detail. By examining the light emitted by Betelgeuse, astronomers have been able to determine many of its properties, such as its size, temperature, and composition. The Hubble Space Telescope, for example, has provided detailed images of Betelgeuse's surface, revealing intricate patterns of gas and dust. These observations have allowed researchers to create models to understand the star's behavior and predict how it might evolve in the future. Betelgeuse's evolution has also been studied using the Atacama Large Millimeter Submillimeter Array, ALMA, a state-of-the-art observatory located in Chile. High-resolution images from ALMA have revealed an extensive plume of gas extending from the star's surface. This plume is believed to be caused by pulsations from Betelgeuse. These pulsations can be explained by a process called convection, which involves the rising of hot gas and the sinking of cold gas. This motion creates waves that travel through the star's atmosphere, causing it to expand and contract. Thanks to Hubble, detailed images of Betelgeuse's surface have also revealed dark regions, known as star spots, or magnetic spots. These are areas on the star's surface with particularly strong magnetic intensity. The star's magnetic field inhibits the flow of gas from the interior to the surface, creating a cooling effect that makes these spots appear darker. Betelgeuse's magnetic field is believed to be thousands of times stronger than that of the Sun. This intense magnetic field shapes the behavior of the gas on its surface and adds to the complexity of this colossal star. The surface of the star appears to be trapped in loops or arcs, describing regions of strong magnetic fields that are visible as star spots. It's crucial to mention that the presence of star spots is not exclusive to V2, but is also found in other stars, including our own Sun. Betelgeuse's star spots are particularly fascinating because of their size. They are several times larger than Earth and cover up to 20% of the star's surface, significantly larger and greater in number than the sunspots on the Sun. These star spots may impact the cause and overall brightness variations of the star. As the spots move in and out from our vantage point, Velerica's brightness fluctuates. This is because the spots, being cooler, emit less light than the surrounding gas, which contributes to changes in the observed brightness of the star. In the case of Rouge, pulsations of the star also play a role in brightness variations. As the star expands and contracts, star spots move in and out of sight, thereby enhancing the observed changes in brightness. The surprising brightness of the observed stars continues to puzzle scientists. The problem is that V Rouge is not as original as one might expect, but there aren't many stars like it. There are some that share certain similarities and are equally fascinating. One of Rouge's cosmic antis is a red supergiant cousin located in the constellation Scorpius. Additionally, Anti is a variable star, meaning its brightness changes over time. Similar to Rouge, it has a mass approximately 12 times that of the Sun and a radius about 700 times that of the Sun. So, it's safe to assert that Anti excels in terms of size. Now, what do you think? Do you believe V Rouge has already gained popularity and it's just a matter of time before we see it in our skies? Tell us about it in the comments box. If you liked the video, Like and subscribe to the channel. Thank you so much for watching. See you soon. One of the most pressing questions about Betelgeuse is whether it's approaching the final chapter of its glorious existence. Red supergiants like Betelgeuse are massive stars nearing the end of their life cycles, and it's widely believed that such stars explode in a violent supernova. This cataclysmic event releases a staggering amount of energy, briefly surpassing that of entire galaxies. Scientists suspect that Betelgeuse might be nearing this explosive fate. The unusual dimming events in recent years, particularly the Great Dimming of late 2019 and early 2020, caught the attention of astronomers worldwide. For a time, Betelgeuse dimmed significantly, leading some to believe that a supernova might be imminent. However, further studies revealed that this dimming was not caused by a supernova, but rather by a substantial cloud of dust ejected from the star itself. This finding, while not as dramatic, was still groundbreaking, as it helped refine our understanding of how massive stars lose mass in the years leading up to their death. So, let's say it did explode. What would that look like from Earth, first? Of all, there's no need to worry. Betelgeuse is far enough away, about 640 to 700 light-years, that its explosion would pose no threat to Earth. Even at its brightest, the blast would be harmless to life, but incredibly visible to the naked eye. If it exploded, scientists believe it would become so bright that it would be visible in the daytime sky for weeks, possibly even months. At night, it would outshine the full moon. The visible aftermath of the supernova, called a remnant, would remain in our skies for decades, if not centuries. For astronomers, a nearby supernova like this would be a once-in-a-lifetime event, providing stellar data in real time. From neutron star or black hole formation to the creation of heavy elements in the universe, after a red supergiant like Betelgeuse explodes, what remains depends on the mass of its core. If the core is below a certain threshold, it collapses into a neutron star, a dense object about the size of a city, but with more mass than the Sun. If it's more massive, it may form a black hole, warping space-time around it and swallowing anything nearby. For Betelgeuse, either outcome is possible. Its mass is near the tipping point, and scientists have no clear idea which path it will take. That's why continued observation is so important. Numerous observatories worldwide and in space are constantly monitoring Betelgeuse. The Hubble Space Telescope captures high-resolution images of its surface and the dust swirling around it. The ALMA array in Chile peers into gas layers ejected from the star, while the James Webb Space Telescope offers unprecedented detail in the infrared spectrum, allowing astronomers to see through dense dust clouds. Telescopes on the ground, like the Very Large Telescope, VLT, and others, also track its brightness, motion, and spectral changes regularly. All of this data combined gives us a clearer picture of the star's behavior and possible future, while other red supergiants such as Mu-Cephei or Antares are also huge and intriguing. Betelgeuse holds a unique place in the sky. It is one of the closest, largest, and brightest stars of its kind, making it a perfect laboratory for studying the physics of massive star formation. It's not only massive, but also wildly unstable, showing unusual variability, dust activity, and surface changes. Its sheer size is mind-boggling. If placed at the center of our solar system, it would engulf everything out to Jupiter's orbit. Yet despite its grandeur, it remains a faint, flickering ember in our night sky. Mysterious and powerful, but still cloaked in cosmic mystery.